Hello, everyone. We're live. Good morning, good afternoon, good evening, whatever time zone you are. My name is Jules Damji. Welcome to our third or fourth episode of Bay Area Apache Spark Meetup. I'm a member of the technical staff, heading all the open source projects here at Databricks. And joining me is David Stanko from Spice AI and Luke Kim from Spice AI, who is the founder and also the CEO of that. I'll give more introduction of them momentarily. But just a couple of logistics. We are coming stream live from on LinkedIn and YouTube and X. So if you missed this, you can always go back to the recording on the on our YouTube channel. Carly, can you actually put the link on the chat for people to be able to actually join and subscribe us? Keep your questions coming. This is going to be sort of a read-only thing. We can't answer all your questions because of the time constraints, but those that we want, we'll be able to answer them offline on one of the channels. So keep your questions coming, and David might be able to answer some of them live in one of the tube channels. Our next meetup is going to be about a month from today on August the 27th. It's going to be about PyData Source API. If you actually want to write your own data sources, you can actually use this particular new API that we actually introduced in 4.0, that you can write your custom API sources. Joining us then will be the Hugging Face engineer who actually took that particular API and used it to build Hugging Face datasets. So you can actually now use Hugging Face datasets in your PySpark to do all your AI workflows. We also have Carly, who's in the background doing all the magic, making us look really good and fun. And just to introduce our speakers today, Luke Kim is going to be our main speaker. He is founded Spice AI in a data startup that actually allows you to build AI workflows with unified data. Previously worked at Microsoft and has led Azure engineering team, and also was part of the co-incubations office in Microsoft as part of the Office of CTO. And he's a big advocate and supporter of open source project, driving mainly the Spice AI contributions to Apache Arrow, Data Fusion, and Spark. And David is a member of technical staff. He has an extensive experience in software engineering, particularly with Spark, dealing with very large data sets up to 100 terabytes of data, and has worked on distributed system, and then brings a lot of experience to make sure that some of the Rust-based analysis that we actually do provides a good, valuable insights into it. So thank you for both of you joining. Just say hello to the community. Nice to actually have people of your caliber joining us to talk about Spice AI. Now, today we're going to be talking about Spark Connect, a use case that Luke is going to share with you, how they actually use Spice AI to do some of the operational workloads. Just to give you a background, Spark Connect has really been taking off. We actually be seeing a lot of use cases out there. Spark Connect was first introduced in Apache Spark 3.0, but over a period of several releases, now is a very integral part of Spark 4.0. And the whole reason behind actually having the Spark Connect was to decouple your driver and the client, so that way you can actually write very thin clients, not only for the JVM languages, but also non-JVM languages such as Rust and Net and Go and things of that sort. So today we actually have a use case about how you can actually use Spark Connect for operational workloads. And Kim is going to give us a whole rundown on how they actually used and why they used Spark Connect for Spice AI. Having said that, Kim, take it over and tell us all about Spice AI and Spark Connect and how it all works. So looking forward to hear from you.
Thanks, Jules, and thanks for having me, everyone. It's great to be here. Let me share my screen here. Let me know if you can see that. Is the slides up, Jules?
Yeah, the slides up. We can actually see it. Yeah.
Great. So hi, everyone. I'm Luke Kim, the founder of Spice AI. We are a data and AI infrastructure startup in Seattle. We help companies like Twilio and Barracuda Networks build data-intensive applications and agents, and we're creators of the Spice open source project, which is a data search and AI inference engine for disaggregated storage. I also have here with me David Stansu, who's a principal engineer on the team, and we've worked across a whole bunch of different data systems previously in our career. And so, yeah, excited to share what we have been working on. So back in 2021, we founded Spice, and back then this was before, if you recall, ChatGPT, and we were working on essentially how do you build an intelligent application. And we came up with this model where you essentially have an application, and alongside it, you would have a sidecar. And within that sidecar, that would encapsulate a whole bunch of the intelligence that could be provided back to the application. Now, in 2025, you would just call this an agentic application and a copilot. And specifically a copilot for software and applications, not specifically for humans, right? You could be your agentic application itself could be a copilot for humans. And so this model has really carried forward across even through LLMs and how we're essentially building applications today. And one of the missions for Spice is to really make it easy for any developer, any enterprise developer to go build these types of applications in the enterprise. But if you look at kind of Gen AI in the enterprise today, it's got a bunch of challenges, right? Mark Benioff had sent out this very viral tweet a little while ago, but basically saying that there's a bunch of challenges, especially with accuracy, with reliability, repeatability, and then also you need a whole bunch of data to make this reliable and accurate, but if you give it too much, then you have the other problem, which is data leakage, right? And so there's a bunch of challenges with Gen AI in the enterprise. If you just go and ask a model to get you some data, and it doesn't have that data, then it just gives you a whole bunch of stuff, right? That's not super useful, right? But when you actually do give the model data, then it can actually be very good, and it can give you data, very specific data back. And then in addition, what you want to do, of course, is be able to verify that data, right? To go back and ensure that it actually was correct. And so this loop, including evals, is really a hard problem to solve in the enterprise to get really repeatable, really consistent at enterprise grade. But it's really critical to realizing the value of AI in the enterprise across a bunch of the products. When we went and talked to a whole bunch of enterprises, in addition, one of the challenges with actually doing this is you have a whole bunch of these disparate data sources. And as much as we'd like to get everything to Databricks or Snowflake or whatever the system of choice is, the reality is if you're a big enough enterprise, you've got data everywhere and often in legacy sources. We often talk to people that have like CSVs on FTP sites, they have file shares, they have SharePoint, they have a whole bunch of stuff. How do you get all of that data, but not too much data, into your model? And how do you actually build these applications? And up until now, if you're looking at a lot of this data, a whole bunch of work has been done to make analytical systems really, really good, right? And so we have these open table formats. We have great systems like Spark, and a whole bunch of work over the last even 10 years to make all this data access really good. But specifically for like analytical big data workloads. But when it comes to AI applications and agents, there is this additional need right now to be able to access both analytical and operational data. And the reason is if that AI application or agent doesn't have access to all the data it needs, it's going to just give you wrong information, as you know, right? So if you're asking a question and you're saying, you give me something about my latest email, it doesn't have that email, then it's not going to be as useful as it could be. And so how do we now combine both analytical and operational systems to be able to enable these AI applications and agents and these workflows going forward? So that's like one trend that we're seeing right now. And the other challenge with this trend is that previously in the analytical side, you would often have a whole bunch of pipelines, ETL pipelines, and often data teams to actually do this, right? Today, almost all the leaders at every company is saying, hey, we need to build AI into all of our products and features. How do we do that? And so now if you have several features per product, a whole bunch of products across your company, it's really not as feasible to go build pipelines and data teams for every single one of those features. And so we need to be able to access both the analytical data, but also operational data in the systems that they live today. The next kind of trend that we're seeing here is a continuation of what we've seen in terms of this disaggregation of compute and storage for analytical data. But we're also actually seeing this now for operational data. And so we are working with a number of companies now where they're actually, instead of querying their operational databases directly, they're actually taking subsets of the data, working sets of the data, putting it into object store, and being able to now use a bunch of the disaggregated compute engines to actually access that directly from object storage. And this gives them the scale of object storage, but also the durability and reliability of that. Especially as data sizes grow bigger now, they're actually starting to stretch the limits of some of these operational databases. And so how do you actually get access to both all your operational data at this scale of these data sizes that continue to grow, and then combine it with your analytical data to be able to actually make an Apple agent that is actually reliable and accurate. And then the third kind of trend that we're seeing is you don't actually want to give your Apple agent direct access to all these data systems. So it's kind of a trade-off here, because you obviously don't want the data leakage problem. So how do you give your Apple agent access to all this data, but not leak data, right? And so you need some type of sandboxing or isolation from this data. So these are the kind of three patterns that we're seeing across the enterprise here. How do I reach back into my full analytical system while still accessing operational data? How do I do this over a bunch of disaggregated storage? And how do I keep this sandboxing and isolation? And what we realized when we looked at a bunch of people is they're often doing this or trying to do this by cobbling together a whole bunch of infrastructure that wasn't designed for it. It's very hard also to be able to access both the legacy stuff and the modern stuff in the same stack. And how do you do this with full enterprise-grade monitoring, observability, security, reliability, and so forth? And what we realized, this was kind of the end of 2023, is that we essentially needed a native AI/ML native database that does this and combines the two. And so we built Spice, started in the end of 2023, and it essentially is this data search and AI inference engine that will sit across any of these disparate sources, be able to combine both your operational and analytical, and get that into a model. So one model for it is that you would previously be accessing all these systems separately, right? I'd be going to S3, I'd be going to MySQL, I'd be going to Spark, I'd be trying to combine these together. And this has a whole bunch of challenges with it in terms of there's a whole bunch of round trips. I now have to take that data, I have to be able to merge it together. I have to do that with a high amount of integrity. So with Spice, you can essentially use it as, in this case, a sidecar, although it doesn't have to always be deployed that way, and have it manage all of the connections back to all these data sources. And because Spice is a full database itself, it can actually do full federation of these data sources, combine them together, and provide it back to your Apple agent. And in addition, what it enables you to do is accelerate that. It'll provide what we call an acceleration, which you can think of as like a pre-cached materialization of that data across those sources in an embedded database like DuckDB to provide back to your Apple agent. Now, when we want to go and access Spark, then Spice is a very lightweight runtime. It can be compiled down to less than 100 megs. It's built in Rust. It can run anywhere from a Raspberry Pi all the way up to a cluster. And so how do we actually access Spark in a very efficient way? And the first talk in this series was a really good talk. I highly recommend you checking out. But Martin talked through why Spark Connect, right? And one of these problems is like, how do you essentially embed Spark in applications like Spice? And there's a bunch of challenges with accessing it directly, and especially this last one here. There's JVM was basically a complete blocker for us. So we had some specific requirements. We're very application-centric runtime because we are providing this as a co-pilot or a sidecar to your application. So very developer-centric, application-centric, and we want as much client-side control as we possibly can because we're doing this federation across a bunch of data systems, and so we want to make that as efficient as possible. Obviously not JVM, it's Rust. And the other really big thing Martin talked about was upgradability, right? And so because we're shipping this to our customers itself, we don't have control over the upgrade process. And so the least friction around upgradability was super important to us. And so from Martin's slide here, what Spark Connect enables us to do is essentially do that separation of the driver and the client, build that into our Rust runtime without any of the additional JVM requirements there, and then make it very, very application centric. And so I think the first version of the Spark client that we built into Spice on Spark Connect, I think Philip, our co-founder, built that in about 3 days. And so it was really fast to kind of get started and be able to access Spark data and be able to combine that with our other data sources in a very fast and efficient way. So when it comes to these applications or agents, there's a different model that's starting to emerge. And the previous model was like you just had one data system, and then you had to protect that data system with things like RLS and all these different controls, so that you didn't get not just data leakage, but also just workload protection. So for example, Denny Lee from Databricks, he talks about this, where if you ask your agent, hey, what's your salary of the CEO? Maybe you shouldn't have that information. And so how do you protect against these things? Well, because Spice is so lightweight, you can actually create one instance of Spice per role or even customer or per state or whatever your use case is, and essentially create a sandbox of data that they can then access your backend data stores across S3, Spark, MySQL, operational data stores, have a bunch of rules to be able to ensure that just the intentionally set data is for each one of these agents, and then build each agent specific to that instance, right? And so you have this acceleration mechanism where you're using embedded database. And so as your agent does a whole bunch of queries against that system, you can essentially give that a fixed size set of compute and not worry about it hitting your backend store, not worry about it interrupting jobs, spinning up a bunch of compute that it shouldn't do. You can kind of keep it self-contained to each one of these instances. And so imagine that you were sharding even per state. You might give your large state a very large instance and your small state a small instance. Or you can give your CEO, it's got to always be fast, a whole bunch of cores, and maybe other people less cores, right? And then you can kind of have this essentially, we call it a data Faraday cage for your data that's just provided to the agent to ensure that agent doesn't do anything it shouldn't do, essentially. So in addition, once you have these, you're accessing a whole bunch of these different data sources, how do you actually combine things that are very fast and things that are slow into an experience where that agent can have a consistently fast experience back to their user, right? And so we have this acceleration mechanism where you can use an embedded database like DuckDB or SQLite or ARIA records in memory. It can be stored in file or on file on disk or in memory. You can also attach to a Postgres as well. And what Spice will do essentially is pre-fetch data on a trigger or using CDC or using an interval, working sets of this data from these backend data systems and store that within the acceleration so they can serve it back consistently fast. And this also doubles as that sandboxing mechanism where the queries can hit this acceleration and you don't have to worry about them hitting your backend store. And so examples of where you might want to have a working set, if you have time series data and you just care maybe about recent data, let's say it's like an email application and you just care about, say, the last day or last 7 days of data, then you could prefetch that last 7 days of data in a rolling window, keep that within the runtime, serve that back to your application, always consistently fast. So with that, I'll give you a demo of all of this. What we have here is we're going to use Amazon reviews, and we're combining a bunch of historical data which we've stored in Delta using Spark, and combining that with real-time data. And this is really real-time data in that we're going to use CDC over to the Apple agent, which is data inserted into a Postgre database, and then using CDC streams, which is change data capture. It's all every insert, every update, every delete gets streamed across into Spice for that real-time data. So it looks like this. So we've got a job within Spark, and it's generating this historical data. And then we're going to connect over to Spark using Spark Connect. And then as part of that job, we're calling over to an embeddings model to actually vectorize the data so that we can do vector search. And then we also have a real-time stream that's doing inserts into Postgres. And as the inserts go into Postgres, it's using CDC over Kafka and Debezium, streaming that within Spice. And the combination of both the historical and the real-time data set is being stored in DuckDB and being served back to the agent. And then we can call back essentially into a LLM to be able to analyze these reviews in real time as they're happening. The other thing here to note is there should be a line actually up here in that as the real-time reviews are coming in, we're also embedding those and vectorizing those in real time as they're coming in, so we can actually do vector search across both the historical and the real time. And then when you do a query, we will vectorize that as the query comes in to actually do the search. In addition, Spice is actually a full MCP client and server as well. And so not only can we do this access across a whole bunch of federated data sources, we can actually do that with tools and services, MCP services as well. So let me come across to here. And so this here is we've just got a script running, and then every 10 seconds it is generating a set of reviews and putting them into our Postgres database. And so you can kind of just see that running right now. Now, Spice is a single binary, single node, very lightweight runtime. So you can just run it using command line. So I'm just going to do Spice run here, and you can see it starting up. It has a HTTP API, a gRPC API, and an OpenTelemetry API. And it's loading a bunch of data sets and models here. And then I'm going to come across over to my editor here. Now, the way that you configure Spice is using this spicepod.yaml. You can kind of think of this as like a package.json for an AI application. Very simple to configure. Here we have a set of data sets. So this one is our CDC data set. So we're using Debezium CDC data set. It's transporting over Kafka. And then as these messages come in, we're using this embedding model to vectorize the data. We're also accelerating that data using DuckDB. And we can just say, hey, we want to accelerate it using DuckDB and mode file. And the refresh mode is these changes as they come through. In addition, we have Databricks here. And we're connecting over using Spark Connect mode here. And all we have to do is provide our credentials here. And similarly, we also have this embeddings where we can actually say, in this case, we're using a pass-through embedding where the embeddings are already generated using the Spark pipeline and stored within in Spark here. And this is our embeddings model here. We're running it locally because it's cheaper that way and faster that way, honestly. And this is all running on my laptop here. So you can think of this as like my edge device. And we're going to be able to reach back into the cloud, into Spark Connect to get data, but then all the real-time processing is happening on my laptop as if it was at the edge. And you can imagine that's similar like an IoT case or a security analyzer case where it's close to the data source and so forth. We can also set up models within Spice. And so here we're just saying, hey, we want to use Databricks. And we want to use the Llama 4 model within Databricks. And again, we have some endpoint things. And then we have a system prompt here to help my analysis of my reviews. But we can also set up other models within Spice. So we also have set up GPT-4. We have Grok here, and we're using the same system prompt. And we have a set of tools. So we're using Perplexity, Google Maps, and these are just MCP tools, and an Amazon product search tool. So let me come across to here, which is, so this is just a quick overview of the Spark job that we're running. Very simple. We're just taking a bunch of data that we got from Kaggle of Amazon reviews. Now the reviews it's an old data set, so they're kind of old reviews. So if you see information in them and it looks old, that's why. And we've just updated the timestamp on the real-time data to make it look real-time. And then you can see a second step here where essentially doing the vectorization, and then we're just storing it within Delta here. So if I come now back to here, then we have a set of command line tools for Spice that makes it easy to use. So the first one is just a SQL REPL, and I can just run SQL statements against Spice. And so if I say show tables here, you can see I've got those two tables here now that are available within the runtime, the real-time views and the Amazon reviews. And I come across here to my, and so I can just query these tables here using SQL. And so here is the real-time reviews, and you can see that's incredibly fast, 0.005 seconds, because we've done that acceleration locally. So that query is going against DuckDB locally that's stored within the runtime. And so I have my real-time reviews here. In addition, I've got my full set of reviews, and this here is calling against Spark Connect in Databricks. So this calls across, and you can see it's got a little bit more latency, 3 seconds for the query, but then I can actually query both within the same runtime and the same API. The next thing that we want to do to be able to analyze these Amazon reviews as they're coming in is we want to be able to search across them. So Spice supports full vector search and full text search within the runtime. And we can access this using I'm just going to hide that. We can access this using this vector search UDTF here. So what we're saying is vector search across the Amazon reviews, look for defect, and then order the score by the score by descending. And this is all done through SQL. There's no additional API. You can do the full vector search and full text search within SQL. And that's actually important because LLMs generally know how to write SQL, and you can fine tune them to write SQL even better. And so if you have a different set of APIs, it makes it harder to actually pull this stuff together for LLMs. But if you have it all within SQL, then you can actually access and you can do all this stuff with LLMs much easier. And so here you can see we've done a vector search. It's very fast, sub-second, across the Amazon reviews. And then we have our score here, which is the distance score. It's kind of hard to see. The distance score here that we've ranked the vector search on. And that was for the Amazon reviews. And similarly, we can do this for the real-time reviews, which are streaming in. So this is doing the vectorization as it streams in and then doing the search. And we can search across both the data sets. But in addition, what we might want to do, of course, is be able to search across both the data sets at one time. So now I can actually do a vector search across my historical data and my real-time data in real time, and I can rank them all within the same scoring mechanism to be able to get the reviews. So now you've seen data query across operational and analytical data. Now you've seen vector search across operational and analytical data. How do we tie this all together and actually analyze these reviews? So Spice has an OpenAI compatible API for LLMs, and we can access this using a tool called Spice Chat. But you could also just use the AI SDK. You could use LangChain, any of the suite of tools that are out there. I'm going to use GPT 4.1 for this because it's a little faster. And now we can access those data sets through the model. Now, one thing to note here is that this spiceport.yaml, it's actually not very long, is all the configuration that's required. There's no additional code here for this demo. You could do this entire demo with just this configuration file. And so now I could actually say, oh, what data sets do I have access to? And the model automatically knows what data sets has access to. It's actually running a little slow though. Because within the runtime, we know about that, right? And so we can just tell the model you have access to these data sets. And then I can start running queries against it. And it will automatically know how to use vector search. It automatically knows it has access to these tables. It can use tools like sampling tools within the actual runtime. So here I'm going to run just a basic query here. Summarize the most recent reviews that had product defects. And within the runtime, it's doing all the work automatically to be able to check what data sets it has access to, check their schemas, sample the data, figure out the right query, do the vector search, do the text to SQL to be able to give the answer back. And what we've asked is for it to come back in this kind of format where I have an analysis and then I have an example. And then we've had references back to like what it actually did. So now if I wanted to take the answer back and I wanted to go back to my SQL command and actually just run that, then I can just go back and fetch the actual product that it came back with and verify, like I said at the start, that it's coming back with the actual data and not hallucinating, right? Another idea or kind of thing that we might want to do is now not just look at some recent data, but how do I now combine this large data set I have within Spark and this real-time data set that's coming through. And so here I want to compare both recent and historical views and see which ones worked over the kind of the test of time here. So I'm going to go and run that query here. And it's going to come back. And so it has said, Homeland just blew me away. I don't actually know what Homeland is, but you can see this is a purely live demo. So now I could go search for that Homeland book back in my database. And it's like Homeland is the best book ever, blah, 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 blah. But I don't have all the additional information, right? So the next thing I might want to do, and if you recall, we had set up these tools at the start. So we actually had these tools here. And so what I might want to do is say, use the Amazon product search to find the book Homeland. Okay, and oops, I run it into the wrong console. So I'm going to do that. And it's able to go and use that MCP tool to go search and give me back that book. And in addition, I want to say, hey, web search using Perplexity, bookstores near me in Bellevue. And it's able to now take that and run a Perplexity search on that and give me back the result. And so here we go. We have a bookstore, Barnes & Noble, Bellevue Square. And so I might now want to say, hey, get me directions from the University of Washington, which is where I'm at right now, to Barnes & Noble in Bellevue. And I'm going to say, I'm just make sure this, let's say, using Google Maps. And I'll be able to get the directions back to here. So you can see kind of the full end-to-end here. I can query data across operational real-time data and this large historical data set I have. I can vector search over that to do search and retrieval. I can get that into a model to be able to give me back some analysis on that. I can go back to the database to verify all that data was actually correct and it wasn't actually hallucinated. And then I can use that with a set of tools to be able to go and do more with that in terms of like more agentic things. And so that's kind of the full overview within Spice. Now, One additional thing I wanted to show you is that this was all running on my laptop, but it's actually connected to our cloud platform. And what I could do here is, because everything is running within, because everything is running within that runtime and everything's passing through it, we can get a full distributed trace of not just the AI things that are happening, but all these data things as well, right? And so we have a tool called Spice Trace, and you can kind of see all the things that are happening within the actual runtime across the tool calls, across the data access, across the AI. But this is kind of hard to see. And so we're also sending this up to our cloud platform. And you can see here, if I click on this one, you can see I did the summarize the most recent reviews, and I can kind of see the full trace of that within the cloud platform. And so here I did the when comparing, give me the hidden terms. It actually listed the data sets, so it knew what data sets it has access to. It then did the text to SQL. It did a text embed on the query itself. Did the text to SQL. Put it all the way back in, and you can see here it actually did a vector search over the real-time reviews and a vector search over the historical reviews, and then did the combined score to be able to give back the actual completion. And similarly, you can see that probably this one here, it say get me directions. It's being able to do something similar, use the Google Maps tool to be able to give you back those directions. And one of the benefits of having all of this within the same runtime is you can do this internalization of calls across your tools, your models, and your data sets within the runtime. And so a lot of these things happen very, very fast. So if I look at the list data sets here, like this is a 0.072 millisecond call. Whereas that, if you can imagine I'm doing these large round trip calls across a whole bunch of different data systems, all of those can take, sometimes several seconds or even tens of seconds. And all of that adds up to be able to not make your actual completion experience fast enough. And that's why you have to have all this thinking and so forth for a lot of these web searches. But this helps you to essentially reduce that amount and be able to provide these answers back to the user very, very quickly. All right, so just a couple of slides to finish up here. Spice will provide this data search and query and inference system back to your app as service across all of this storage and connect that over to your models. And in addition, it'll also connect over to catalogs. And so we have full support for Unity catalog, for AWS Glue, and we're adding additional support for Apache Iceberg catalog here. And so you can connect over these catalogs for governance and credential vendoring, get access to these data sets, and then get these into a model. It has 4 industry standard APIs. And so it's incrementally adoptable. You can use all the ecosystem of tools that are already out there. So database query APIs, Flight SQL, ODBC, JDBC, ADBC, OpenAI compatible APIs. We support loading and serving models within the runtime itself, like you could just pull from Hugging Face accelerated or hosted model gateways. And you saw there, I could just list them all. I could swap between them. A unified Iceberg catalog API, so you can connect to and get access to all those data sets. And then the MCP server and client API. You saw me using it as a client, but similarly, I could have just connected Cursor to Spice and then done exactly what you saw me do within Cursor using its MCP client. So use cases for this, very good for reverse ETL. Like you've got a bunch of stuff in Spark and in Spark Connect, and now I want to get it out for specific use cases, and I want to combine that with other data sets. A data mesh across a bunch of these data sources, and then this hybrid analytical operational data acceleration and federation. We support full hybrid search, which means keyword, lexical, full text and vector search combined with re-ranking, full RAG workflow across across all of those, as you saw, and then a bunch of tools that make this easy to build AI applications and agents. And everything is grounded in data, because data really is, of course, the most important thing and the core tenet across all of these things that we do. All of this is built on open source technologies, and we've made bets on all of these. So things like Apache Arrow and Flight, ADBC, Data Fusion. We have this hybrid execution with DuckDB, an Arrow with OLAP style databases, but also SQLite and Postgres. And we're just looking at adding support for Terso now, which is a rewrite of SQLite in Rust. And then all of this is like super developer friendly. As you saw, there was no code there. It was just that configuration file. And then all the APIs are industry standard APIs. So as friendly, as developer friendly as we can build it essentially for you. And of course, when we're connecting to Spark, we're using Steve's Spark Connect RS library, which I believe just got upgraded to an Apache project. Congratulations, Steve. And we're in the process of migrating over to the official Apache project now as well. We are also the creators of the Data Fusion Table Providers repository, and this enables essentially you to do that federated SQL query across any of these number of different data sources. We now support, I think, 35 or 40 different data sources, from MySQL and Postgres to Databricks and Snowflake to Iceberg and Delta, and get that into Data Fusion within a single query. And we're big contributors to the Federation project there as well. And then all this is, you can get this on your laptop literally in 30 seconds, run one curl command, run one brew command, and you've got that CLI that you saw me do when I did Spice run, and the Spice SQL command, Spice chat command. We also have a Spice search command. And then you can, within probably 2 minutes, we have a tutorial, query data that's on S3, combine that with a local database like MySQL or Postgres, and be able to get all this within a model to be able to build some of these AI applications and agents. And this will run across Mac and Linux and Windows, and GPU accelerated with CUDA or Metal. Finally, one thing I just want to leave you with here, sort of finishing up, is what we believe is to really make these applications or agents useful, you essentially need to provide this secure environment for them to run. And within this environment, you're going to have your models, you're going to have your embeddings and tools and evals, but what you really need to do is project essentially secure virtualizations of data from wherever it lives into this environment, so that the agent's not breaking those systems essentially. And then of course you really need to be able to audit all this to make sure that it's not accessing data it shouldn't, and so forth. And then you need to be able to track kind of all its calls out to the models and all its calls out to the internet as well. And within the enterprise, of course, you need this to be monitored. You have observability, you need control and policy around this. And then you really want the agent to be able to do as many iterations as it can. And so you want this AI feedback loop where it's doing iterations, it's getting feedback back into the system. If you saw, sometimes I see where I do a demo where the query generation, the text to SQL fails, but because we can actually validate the SQL within the runtime, we can get that feedback, give it back to the model with a very fast turnaround, sub-second. Whereas, if you're calling to an external data system just to get a invalid syntax on your SQL, it'll take a long time. And so how can you make this AI feedback loop as fast as possible to be able to build these agents? And so we really believe that for reliable AI, you essentially need two things. You need to have this very trusted, it must be grounded within this full knowledge data, but without giving it too much. And they needed to be able to give it the ability to really iterate and learn and quote, think. So that is Spice. It's a open source computer engine built in Rust, provides SQL query, inference and search, acceleration using DuckDB, connection to catalogs. We have a set of tools that makes this really easy to get it into models. And it provides full evals and observability for this whole stack. It runs all across disaggregated storage, wherever that lives across your enterprise. So thank you. We appreciate any feedback on the project. It's open source, Apache 2 licensed, GitHub stars, PRs always appreciated, and feel free to reach out with any questions.
Well, thank you, Luke, for the very comprehensive ecosystem of how actually Spice AI integrates with all this different, both operational as well as analytical databases. I think one question that actually that comes to my mind is that you had this comprehensive picture of the entire ecosystem working with different components. And if I wanted to get started, which you actually showed us, you can just do an npm install. When I do that npm install, what do I get on my local host? What parts I don't get and what parts I do get. So could you speak to that a little bit?
Yeah, great question. Let me just bring up the docs here super fast. So if you go through this getting started guide and you just run the CLI, run the install script here, you can do this in 30 seconds. The only thing that you'll get on your machine is the CLI. And that's super, super lightweight. Now, as soon as you run Spice, it will automatically go and download the runtime itself. And the runtime is about 140 meg in its standard form. So the install script will give you the CLI, run the CLI, that will get you the runtime. Once you have the runtime, there's two versions of it. One, if you don't want any AI features, we have a slimmer version with just data, and that's what you get by default. And then if you want to use the AI features, especially accelerated features, then you can essentially do a Spice install AI. I think we have the command down here somewhere, or maybe not. You basically do a Spice install AI, and it will get the right version of the runtime. Like if I'm on a Mac, it's going to get the Metal version of it and install that, so they can have Metal accelerated runtime within on my box. So that's the way you kind of get it. It's really fast. You can do this whole tutorial in about 2 minutes is what we've designed it for. And then once you have that, in terms of the components you get, we have all these different data connectors. So everything from Databricks to Dremio to GitHub to Postgres, GraphQL, FlightSQL, Snowflake, ODBC, MSQ, ClickHouse, Debezium. All of these are built in, and that's included in that 140 meg. And so you get all of these. You also get the data accelerators, in-memory data accelerator, DuckDB, Postgres. We'll connect over to secret stores. We'll connect over to different catalogs. You have vector engines here. You have different model providers here. And because it's all very, very lightweight within Rust, all of that is just built in, and you just configure it using that one YAML file.
And so the runtime is actually completely written in Rust.
Completely written in Rust, 100%.
And so if I was a Spark developer and I download Spice AI locally, and now I have a Spark cluster actually running that has access to my S3 buckets, that has access to my analytical data on Delta, and I'm using open source. Well, whether it's managed Spark or unmanaged Spark, the question is the Spark Connect client, is that actually embedded as part of the runtime?
It's embedded as part of the runtime.
Right.
So you get that out of the box.
So when you were actually making those queries in SQL, when you said Spice SQL, you were actually making some queries. Were those queries being, if this was talking to a Spark server, would that get translated into protobuf over to Spark kind of service, and then those would be executed or there? Is that how it actually works?
Yeah. So imagine that we're doing a query that went across the real-time database and the Spark Connect. What we'll do within Data Fusion is we'll parse the query. It's a full database. We'll get the AST. Then we will actually analyze which pieces go where. And then we will send just the piece that goes to the real-time database. We'll send that query to that database. And then we'll send just the query that goes to Spark Connect over the Spark Connect library. Then when the results come back, let's say we have a vector search from one, a vector search from another, we'll combine the results into one result set and provide it back to you in the client.
So within the protobuf, we're actually sending it to your the Spice server on the back end. It has the ability to say which way to route that. So it knows that I'm going to route it federated to my Spark server. That's going to create my entire plan and execute that. If this was a Postgres server, or this was talking to another one, you would just federate that.
That's right.
To that.
That's right. Yeah.
Now, what about when you're federating it? What about the credentials? So let's say I'm talking to a Postgres server sitting somewhere on the cloud.
Yeah.
Those credentials are part of the protobuf that you're actually sending in, or how does that work? Or you're talking to a Unity catalog? What's the flow there?
Yeah. So in the demo that I have, you can actually see the way we set up credentials in the Spice pod. So they come over to here when we connect over to. This is a local Debezium, which is Kafka. And so if you bring up OrbStack here, you can actually see I've got Debezium running here. I've got Red Panda, which is a lightweight version of Kafka running locally, and I have Postgres server. And so the data is getting inserted into Postgres. It's going through Kafka over the Debezium protocol, and then we're connecting to that. In this case, it's just connecting because it's localhost. But if this was a Postgres server, we would have the Postgres credentials here. And we support secrets here. So these secrets, I'm connecting over to Databricks here, and it's using Spark mode. And then we're using these secrets that are just passed through here. And so if this was whatever data system you have, we can use secrets here at the dataset level. Now, we also support catalogs. And so if I come back to my docs here, then when you're doing a catalog connector, you will be able to pass in your credentials for the catalog, and then we will be able to go to the catalog, find all the data sets, and get access to those data sets through the catalog, pass that through, essentially.
And in terms of I saw a slide there where it actually talks about the Spice AI in the cloud. I assuming that's your managed version. And somehow my camera has gone actually blurred.
Yeah.
I don't know if I'm blurred or something like that. So I tried to fix that, hopefully. So what is it that you actually get with the open source Spice AI, and what is it that you don't get if you're actually using? What more additional stuff do you actually get with the managed one?
Yeah, great question. So the open source runtime, you can think of it as a single node engine. So everything you saw today, you can run in Spice. You can run just in the open source version, which is free. Single node engine for query, search, and inference. Anything that is clustered, multi-node, sharded, that's in our enterprise version. So once you go to like, hey, I really want to scale this out, I want load balancing, clustering, sharding, so forth. When you want to have observability, then we have, like I mentioned, this version here within the cloud where you can send up observability to the cloud platform. Obviously in the cloud platform, we also have it hosted and managed. So if you don't want to run it yourself, then we'll do that for you. And we can deploy that to our own environment or to your AWS environment as well. And so basically, as soon as you move beyond kind of single node access, and single node can take you a pretty far away. We have customers now who are running single nodes on pretty comfortably up until about 1 to 5 terabytes of data. But once you go beyond about 1 to 5 terabytes of data, at least in the acceleration mode, then you can then you'll essentially need to be able to do more sharding, partitioning, and load balancing, all for very high scale. If you're not using acceleration, so Spice will also work. I mentioned the acceleration using things like DuckDB. It'll also work without acceleration, meaning you can just call directly through, say, to Spark Connect. And in that mode, there's really no limit on the scale. We have a customer now who's doing like multi-terabyte queries through Spice. Multi-petabyte data sets through Spice doing queries. And it's just the acceleration that will take you up until about 1 to 5 terabytes.
And those 1 to 5 terabytes data is actually brought not in one go, but it's actually brought in pagination. So when you're doing the queries, how does that work?
Yeah, so there's different ways to update acceleration, and it depends on your use case. So like I mentioned at the start, if there was like a use case where you had the last 1 day of data or last 7 days of data, then you might want to stream just like keep a rolling window like the last 1 day of data. And we can update that using CDC on a trigger, on an interval, and we can push down essentially like SQL predicates to the update. So for example, if you wanted to just get high priority email in the last 7 days, we could filter that down and just update that high priority, accelerate that within the runtime, make those queries incredibly fast using that embedded database, but then be able to reach back into a system like Spark Connect for kind of your large scale archived email that might be from 10 years ago, for example.
I think there's a general question that might be useful for the wider audience that David actually did address, but probably David, you actually might want to just talk to the rest of the people. What are some of the benefits and advantages of using Spice over, say, something like Apache Trino?
Yeah, so kind of coming back to that slide where I had, in the world of AI, we're being driven to new patterns and new use cases, right? And one of those use cases we're finding is you want this ability to provide a very lightweight sandbox of data and tool set and models to each one of your use cases. And so we have a customer out there who's actually running, I think they're about to hit 450 containers of Spice deployed. It's very unlikely you would deploy 450 deployments of Trino, and certainly you wouldn't deploy one per customer or one per use case. But with Spice, you can do that. So you could actually have, let's say you had my CEO and they have access to Stripe and to all these different services in the tool set, and a set of databases and a set of models. And I could build another Spice instance for someone who doesn't have access to Stripe, for example, and they don't have that tool set. And you could do this at any granularity. So that could be at like a per state level or a role level. And so what we're seeing is essentially a more distributed nature of building these systems when it comes to agents. Instead of having kind of one big centralized system where you're trying to control all these things that has access to the workload, the cluster, the query pattern, and so forth.
Let me see if I have any other questions from the crowd. I think you
Also,
both
Spice is written in
David
Rust.
Okay.
So
Yeah, of
that's a
course.
benefit.
I'm rusty. Is that the reason why you decided to use Spark Connect, because you had the Rust implementation ready for you?
Yeah, well, I mean, that's the Spark. Thank you, Steve, for the library. So that saved us a lot. But yeah, that was one of the first reasons to use it. It was the easiest way to get it working within Rust runtime. So
Brilliant. That's nice to know. I think we only have time for one more question. I don't know if I actually have any on the chat. I don't see that, but let me see. So what's next for Spice AI? What's on the roadmap, both for the open source as well as for the managed one?
yeah, so we've focused up until now primarily on read optimized scenarios. So what you saw there in the demo is primarily read optimized, and we haven't yet done a whole bunch of write scenarios. And so what's next for us is we will be writing natively, be able to write this data as you get it in natively to open table formats like Iceberg. And so that's one thing that's big for us. And then we're doing a lot of work around an enterprise SKU now. So improved levels of scale. We just added query partitioning, for example, within the runtime to do very large scale queries, where what we'll actually do is you can hash partition on a column, and we'll actually create one DuckDB instance per partition, and then be able to prune and just send that to each one of those embedded instances. So large enterprise scale. I think we just hit something like 100 million queries a day running through Spice just in the last week. And so now we're just higher scale and more enterprise grade features, better Spice cloud deployments and so forth. Yeah.
And as you mentioned, Steve Russo, along with other contributors, have actually donated that Rust client to the Apache Spark. We went through the same SPIP that the PMC will very graciously approve it, and they're working on the first particular releases. So I think one of the things that we want to urge to the community, that if there are any issues with the Rust client that you are using and you want to see some enhancements that would benefit the open source Spice AI to have more features available for the Rust client, please file an issue or file a PR. We would be more than happy to have Spice AI being a contributor on the Rust client as well.
Yeah,
I think
mean,
with that
we
note,
contribute to all of our upstreams. So, we've done a bunch of work in Arrow, in Data Fusion, in Iceberg. And so very happy to help contribute back up to Spark Connect as well. So.
And if I wanted to contribute, what do? I do a Git clone of Spice AI?
Yep, all open source. Just go to the GitHub repo, clone it. There's data connect. There's a billion data connectors there, and you can always add another one. Yeah, very easy to get started.
Is David going to approve my PR, or is he just going to give me a hard time? Well, on that note, I think thanks a lot for your elaborate explanation of what Spice AI does for us, and I think we are right at 1 hour. So thank you, David, for joining us, and thank you, Luke Hume, for your articulation of what Spice AI can do. Why did you choose Spark Connect? Why it actually plays an integral role in making sure that Spice AI is both open source as well as the managed version successful. So thank you, and hope to see you again with the next version
Yeah.
of Spice AI then. Thanks a lot,
Thanks
guys.